Well, hey, it's Mr. Thompson with a video math lesson. We're going to talk about trig ratios, okay? Also known as trigonometric ratios, but trig is much easier to pronounce and write, so we'll just call them trig ratios, that's fine. Trig ratios are very closely related to right triangles, which I just happen to have a lovely one drawn right here, as it's right angle marked, okay? We know we have hypotenuse on right triangles, and we also have some angles, and I've drawn this little symbol in here which is called theta, as is so conveniently described here. This little symbol, really all it is telling me, okay, here's an angle that we're looking at. We're right here. We're not looking at that angle, we're not looking at the 90, we're looking at this one here. It's a Greek letter, this symbol, just so happens to be, but and it's pronounced theta. Doesn't matter, it's just a symbol. It could be a smiley face, could be whatever, okay? But that's the symbol we're using, okay? Now, I want to be able to talk about this triangle. I want to be able to talk about the different sides of the triangle, and I want you to be able to tell exactly which sides I'm talking about. So I'm going to label them, and I'm going to label them in reference to this angle, okay, which is why I've labeled that angle. It's very important. The first side I'm going to label is this one down here. It is next to this angle. It's sort of alongside that angle. It's part of that angle, you could think of it as. And so the word we use is adjacent, which means next to. So it's next to the angle. This is the side that's next to the angle that we're talking about. Okay? And then, of course, this one is opposite that angle. It's on the completely other side of the triangle from that angle, so it's opposite the angle. It's on the opposite side. Okay? All right, we've done all the setup we need. Let's look at these trig ratios. Okay, there's three of them. The first one is called sine, S-I-N-E, sine. Next one is called cosine, and then finally we have tangent. Okay, now you may be familiar with their abbreviations, S-I-N, C-O-S-T-A-N. They're still pronounced, even when they're written like this, they're still pronounced sine, cosine, and tangent. Okay. So what are these ratios? Well, they're ratios of the sides of a right triangle. Okay, so sine, what we do is we put sine of theta, and what that does is tells us, okay, again, it's just the angle we're looking at. We're looking from this angle right here, okay, not from that one, from down here. So the adjacent side is over here, the opposite side over there. Sine is the ratio of the opposite side, the length of the opposite side, however long that is, over the hypotenuse, the length of the hypotenuse, okay, the side opposite the right angle. All right, that's what the sine ratio is. It's as simple as that. Okay, cosine of theta, okay, is the adjacent side over the hypotenuse. It's the ratio of the adjacent to the adjacent side to the hypotenuse. Okay, finally, tangent of theta is the ratio of opposite to the adjacent, opposite over adjacent. Okay, that's pretty much it. Those are what the ratios are. We'll go through some examples looking at how to use these and things like that. But first, let me introduce you to a little acronym that people often use to memorize these ratios. Okay, S-O-H-C-A-H-T-O-A. So sine is opposite over hypotenuse, S-O-H. Cosine is adjacent over hypotenuse, so C-A-H, and tangent is opposite over adjacent, T-O-A. So ka, toa. Okay, if you can remember that, then you can do your trigonometry. Nice and easy. Okay, so let's look at a really easy example. All we want to do is write the ratios for sine theta, cosine theta, and tangent theta for this one right triangle here. Okay, and it's got some sides labeled. I'm just going to copy in quickly our little guide from the previous page. Okay, so SOHCAHTOA, sine, cosine, tangent, and the ratios. Okay, so we want to write sine of theta, which is opposite over hypotenuse. So the opposite side is a length of 3, and the hypotenuse is a length of 5, so 3 over 5. Okay, it's as easy as that. And this is a real easy example. We'll do a harder one soon, but cosine theta is adjacent over hypotenuse, so 4 over 5. And then tangent of theta is, of course, opposite over adjacent, so 3 over 4. Okay? All right, easy enough. Let's move on. We're going to use the trig ratios to find x for the following triangles. Okay, so here's some triangles with angles drawn in and some lengths given. And we're going to use the trig ratios to find x. Now this is a little more interesting. Okay, the first thing we have to do, well, first we need to remember our ratios. So I'm just going to write those in for reference. And we need to look at the triangle, and what we have to, the first step is to decide which ratio to use. Okay, so here we have an angle measure. It's not theta anymore, it's an actual angle measure. We have the hypotenuse, and we have this side over here is unknown. That side there is opposite the angle. So we have the hypotenuse and the opposite side, so what we can do is write the sine ratio for this scenario. So we can write sine of 30, okay, because we always put the angle in there. Just theta was kind of standing in for angle measures. So we're putting the angle measure in now, and we can write equals x over 10. Okay, that's the sine ratio. Sine of 30 is x over 10 in this case. Okay, now what we want to do is we want to find x. So we're going to solve for x using our good old-fashioned algebra skills. We want to get x by itself. So x is being divided by 10, so we're going to multiply by 10 to cancel that 10 out. We have to do it on the other side as well. The 10's cancel. And now basically what we have is x equals 10 times the sine of 30. Okay, now what you can do is take your trusty scientific calculator and punch in 10 times the sine of 30. Now you need to practice with this. The first thing I would recommend doing is making sure your calculator is on the right mode. So type sine of, just do sine of 30 equals, and if you're, I'm just going to do this, explain this with degree mode. There's different ways to do it, and that's why it's important we get it on, everyone's on the same mode. So if you're in degrees, sine of 30 should be 0.5. Okay, and I am using degrees, so you really need to switch to degrees if you're not already there. So sine of 30 should be 1/2. So if you type in sine of 30, you should get 0.5. Well, if sine of 30 is 0.5, 0.5 times 10 is just 5. So 5 equals x. And so we've found the length of x. Okay, next problem. We have a 75-degree angle. The hypotenuse, we know the hypotenuse is 8. And we're looking for this side here, which is adjacent to the angle. So we can use cosine. We can write the cosine ratio. Cosine of 75, okay, so we put the angle in there, equals adjacent, so x, over the hypotenuse, or 8. Okay. Same thing as before, we want to multiply it by 8 to get x by itself, so we do that on both sides. The 8's cancel. And if you type in 8 times cosine of 75 in your calculator, you get 2.1. Okay? So that's the answer. Finally, this last one, we have an angle measure, and we don't have the hypotenuse anymore. We have the adjacent side and the opposite side. So what do you know? We can use tangent. We can write the tangent ratio. Tangent, and we're going to put the 40-degree angle in there. Tangent of 40, and we know that it equals x over 5, the adjacent, opposite over adjacent, x over 5. Okay. As before, we're going to multiply by 5, cancel those 5's, and x equals 5 times tangent of 40. And if you plug that in, you get 4.2. Now, the problems will get a little bit harder than this. I'll do another video of examples. Sometimes if you're looking for the hypotenuse in these sine or cosine ones, or if you're looking for the adjacent one in tangent problems, that can be just a little bit more work. It's a few more steps here, but it's more or less the same thing. Set up your trig ratio and solve for x, or solve for the unknown. So that's all there is to it. Best of luck, and we'll see you next time.